So good morning. My name is Davor Sutija. I'm the CEO of Thin Film Electronics. And Thin Film is a public technology company that is focused on doing additive manufacturing to create ultra-scalable NFC devices. Devices that can scale to the billions of units and in fact be added to disposable products to create an entire new extension of the electronics world, what we call disposable electronics. When people talk about the Internet of Things, they have different definitions. I just spent 3 days with Elliot Garbus, who for 5 years ran Intel's IoT program in their automotive division, a $2 billion line of business. Very significant. But what is that? What was their definition of IoT? It was to be able to create connected devices that were relatively sophisticated. Xeon chips. I mean, yes, they measured, for example, the temperature in retail for yogurt, other types of perishables, and then communicated this online. But it's not the kind of research that we are doing in large area electronics. And the difference, I think, is very fundamental. The difference is a matter of scale. It's a matter of ubiquity. When the price point is in the tens of dollars or hundreds of dollars, then you can afford conventional electronics. But when you need to scale to the billions of units, or maybe even the tens or hundreds of billions of units, then you can't afford those price points. Instead, you have to find ways of extending electronics to large areas and be able to scale cost effectively. Now, I'm going to spend the first half of this presentation telling you about why we're doing this, and then the second half to talk about the technology and our progress in large area electronics. And the why is very important, because one of the things that I learned in the, I was in Tel Aviv for the Orbitech Advisory Board meeting, there's a lot of progress in flexible polyimide for a lot of applications in electronics. There's a lot of progress with willow glass that is also in large area. Georgia Tech, Rao Tumala has an entire program funded by Qualcomm to make an entire mobile phone on a 30-micron thick glass flexible layer. It's an incredible project. But it is fundamentally different from what we're trying to do because, again, the volume of those phones is going to be relatively limited. Now, you do want to make phones flexible, you do want to make them performant, but I think there's something different when you try to connect the physical and digital worlds. And when I talk about the perfect storm, let me sort of explain why NFC is so important. On a smartphone, and smartphones have been around a little bit longer than the iPhone, but it really changed with the iPhone, because all of a sudden your phone didn't become just a way of communicating, first through voice and then through text and so forth. It became a gateway to the internet. But with near-field communication, which is one of the 4 protocols on the phone and the one that consumes the least power, NFC can be always on. What happens if Bluetooth is always on? Your phone dies. Bluetooth is great, but it requires pairing to every individual application, and it will immediately look for things in your surrounding and turn on that communication. So while Bluetooth and the mobile frequencies, Wi-Fi, can all carry lots more information at a much greater frequency rate, NFC is the right technology if you need to transfer small amounts of information securely with very low power in a battery-powered device. Now, what is the driver? Is it going to be mobile marketing? Well, I hope it's going to be important, but the reason that NFC is ubiquitous is exactly that question of privacy and security. To be able to enable payments with mobile phones. Very often people now in Asia especially, people who use WeChat, they use barcodes to pay with. They scan a barcode. But barcodes can be easily tampered with. I mean, after all, they're just printed. So a lot of fake barcodes have now appeared, QR codes, that can even introduce viruses into phones. So imagine if NFC is not only the way to do secure payments, but also to be able to connect brands with consumers. And that's what I'm showing here. Now, there are two ways of doing this. Windows and Android, you just bring the phone close to the object and immediately the browser opens up. Apple has decided to do a different experience, that you need an application. The advantage of that is that you still get an experience when you don't have connectivity to the net. But the difficulty of that is, as this picture shows, there has to be a proactive consumer interaction, not just bringing the phone close to the device. You have to have the app opened and you have to, in fact, do the scanning. And those have pros and cons. But the fundamental difference now, and the reason that I'm talking about this perfect storm, is all of a sudden there's 1.8 billion phones that have NFC inside and NFC always on. So the problem with RFID 10 years ago is you had to have a distribution of readers out in the world. $50 readers, $100 readers. For a purpose of just scanning, doesn't make sense. Now you have a device in your pockets that not only is a gateway to the internet, as the iPhone was from 2007 onwards, but because it can allow individuals to decide when to exchange private information with the surroundings to actually be an intelligent agent. You can interact with digitally enabled objects and get workflow, how to put together furniture, get information on how to rebuy a certain product, or give feedback to the company that made that particular product. So I'll be sharing our work in how to make that NFC technology available to brands at scale. And what I want to show is that it's complex. It's not only about large area electronics. That is a differentiator. That's an enabler. But I'll try to show all of the elements of the ecosystem. And also, I want to make it very, very clear. Thin Film wants to work with everybody in this room. We don't believe that we have all of the technologies and pieces of the puzzle necessary for this technology to diffuse through the world. We believe that we will be a driver. We've raised $300 million. We have gotten the former Mirasol facility from Qualcomm, but there's much work to be done, and we need an ecosystem, an industry to build together to make this happen. Okay, so that was my, if you will, introduction as to the why. Let me give you some proof points. What is changing today? Brand owners may soon be out of business. If you go online, now it's almost certain that you will do so through a mobile channel. But in a mobile channel, how will you find information about products? You will either do it through search, through social media, or through an e-commerce site. That means all the data you're leaving behind is held by these technology platforms rather than the brand themselves. So imagine a drinks company or an olive oil producer. They are disintermediated from their consumers by these technology platforms. Now, imagine instead that you could add a digital signature to their packaging, and then the consumer could interact directly with the brand values that the brand has. And why is this important? Amazon is 38% of online e-commerce sales in the United States, and they just bought Whole Foods. Now, when they bought Whole Foods, they lowered the prices on Whole Foods' own brands to the level of what is known as Trader Joe's, which is one of the competitors in the retail space in the United States. This is important because in 13 categories, they're killing the major brand. Last year, Clorox, their #1 channel for sales was Amazon. What happens when Amazon decides, instead of Tide on a dash button, to just call it Amazon soap? The value of the brand diminishes significantly. So the intent by adding NFC to packaging is to level the playing field against these companies that are now worth hundreds of billions of dollars. In fact, the technology companies are worth 10 or 20 times what the brands are worth. So how do we do that? Well, an important aspect, of course, is ubiquity, but the most important aspect is to give control back to the consumer. So in order to do that, you have to scale, not to the millions or hundreds of millions, but literally to the billions of units. Why? Because we throw away, according to McKinsey, 3 trillion objects every year. And if you even want to put an NFC tag on a few percent of that, you need a scale that far exceeds the number of microprocessors manufactured by the entire electronics industry in the world today based on silicon. Silicon allows us to produce 20 billion devices at the complexity of a microprocessor. Yes, there's more discretes. If you include capacitors or simple discretes, the number is larger. But the total production of the silicon industry is just a couple of tens of billions of units. What I'll be sharing with you later today in the following slides is a factory, a front-end die manufacturing facility in San Jose that can add 35% to that global capacity at a capex of just $33 million. Why is that important? Because a new fab costs $10 billion at the 10 nanometer level. Even if you do an 8-inch fab today, and there are a couple that are being built in China for MEMS and other applications, they cost maybe only $3 billion. But according to Gartner, you need a $3 chip to amortize the cost of a new fab. So everybody talks about RFID being 2 cents. Yes, it's 2 cents to make the chip in a fully depreciated fab if that fab has nothing else to manufacture. At CES in Las Vegas a week and a half ago, a major chip company who makes NFC chips, at least they do on their website as part of their product portfolio, they said, Davor, if you want to buy 1.5 cent chips from us, we're not interested. Our fabs are full. Now, semiconductor industry is cyclical. There could be another downturn. However, the Semiconductor Industry Association has said there's a monotonic decrease in the number of 8-inch fabs. The last general purpose 8-inch fab was commissioned in 2003. They number about 120 in the world. Over the next 4 years, there will be a loss of 4 or 5% of these fabs. A couple will open and 6 or 7 will close. And why is this important? Because 8-inch is not where the equipment manufacturers are working. If you want to build a 6 or 8-inch fab, you usually have to buy at least some refurbished equipment that comes from another fab, which means no net gain in the industry. So the silicon industry, by definition, is capped. And that's an important differentiator that is becoming apparent now as we have a relatively good economic situation. So, returning control to consumers. Let me build on that concept. Will consumers get it? That was the question we had 9 months ago. So we started field trials using what I'll explain to you is a partially printed NFC label. Now, our labels, until this point in time, are only readable by Android and Windows Mobile. The reason is that Apple has only allowed the reading of passive tags since October with iOS 11. And it'll be only next month when half of the iPhones in the world will have iOS 11 in them. So all the data that I'm showing here has been on Android solutions. But, and each one of these dots is not a single tap. For example, in Madrid, in the Barbadillo case, there were 800 taps in Madrid, and if we zoomed in, we would see which IP address and what location they were related to. But the point that I want to say is that with the right call to action on the packaging, or on the insert, or on the flyer, or on the card that's being distributed, people get it because they understand that tapping is the motion you use for payments. If thin film alone had to change consumer behavior, it would be an impossible task. But because we're allied with Apple Pay, Union Pay, Android Pay, Samsung Pay, it is something that people are doing on a recurring basis. I gave a lecture in Miami just a couple of months ago and I asked people, how many people in this room have paid with a mobile phone? And I don't know what the answer is here. I'm happy to see a show of hands. But in Miami, my hometown, it was over half that have paid in the last 3 months with a mobile phone. CVS, for example, is a drugstore in the United States that is really focusing on using Apple Pay. Now, the other thing I want to point out is that this information can either be national or it can be very, very local. In the case of Coronado Brewing, that did a campaign with us around Earth Day in April of this 2017, what we found was that you could tie where people were drinking their beer, which of 3 pubs they picked up the coasters that we were using as part of the promotion. People liked the coaster, they took it home. You could then find the catchment basin for each of those end locations, distribution points of that particular product. So in the other case, for example, Oscar Blues, we found that right after the announced start of the campaign, there was tapping activity in Minneapolis. But again, referring to my hometown of Miami, not so much. The guys who were given a $500 spiff left the coasters in their car. They had to get emails, they had to be prodded to actually do the marketing campaign. Now, why is this important? Because there's consumer benefits, but there are also benefits to the brand, to be able in real time to get data about consumer interactions. When are people using the brand? Where? Is the marketing campaign actually live? How long did it take Barbadillo in Spain to get their product in Corte Inglés and Lidl? How many weeks of inventory was there in their distribution channel? All of this data in real time becomes available from the simple consumer act of tapping. Okay, so I'm not going to belabor the point anymore, but there's over 24 companies everywhere from Hong Kong to Korea to Australia that are now in market with NFC products from Thin Film. And the majority of the deployments have been with partially printed NFC labels. That means printed dopant polysilicon. The other portion that requires Apple readability is done using more conventional silicon tags. Now, we are partnering with other people in the industry so that the protocol that we use on printed dopant polysilicon becomes a standard. So we expect over the 12 to 18 months that all tags will be read by all phones. So a little bit more about the objectives. In these cases, for example, you put out 100,000, 300,000, 500,000 tags in the marketplace, and there are many different formats, and I'll show you the formats a little bit afterwards in my talk. But you find that NFC doubles the results of marketing campaigns. And since I used to be in the search industry, I have to actually give a plug to our friends at Google. They're the only other channel that works. Now, I don't know if you guys know about advertising very much, but on PCs, the way that advertising was done was known as banner and display ads. On mobile, 800 million people have already downloaded software to block such ads. 800 million. Why? Because they're so intrusive. 85% of the clicks on those ads are unintentional. It's not robots. It's that the ad pops up and you touch it by accident, and then you hit the back button. So in the data analytics from Google Analytics, you can see that the time on site is less than 8 seconds. So it turns out that banner and display ads, when you account for all of the fake clicks, represent only 14% of traffic. NFC was more than half of the traffic in all of these deployments that we had this year. So NFC works. That's what the great opportunity is. So, what is Thin Film? Thin Film started as a printed electronics company. R&D. 310 patents. But now we're a solutions company. We also have a team of 20 people creating a Connect software platform. And you have a touch point, for example, tap here, or there is one of the Campari brands, Espolón Tequila. It gives you information on how to download the app, and off you go to the races. With Espolón Tequila, you're being sent to Drizzly, and you can order the tequila online. If you get this in a bar, by the time you come home, the tequila's already at your door. Now, how do you make this happen? It's not so simple, because every single tag has a unique ID. So you know where it's sold, when, and how. But that means we have to have ID generation and validation in the manufacturing system. We have to, in manufacturing, encode the IDs. We then have to configure the labels to the right website or the right consumer experience. We have to measure the tap events and do the analysis. So over the last year, we've had a team of 20 people launching this Connect platform. We come out with a new version by the end of this quarter. It will be enterprise ready to scale to billions of units, because later this year, when role-based manufacturing starts, we will have 100 million unit capacity per month just out of San Jose. So there's a bunch of other software components. I won't go through that, but it just shows that Thin Film is a solutions company. That's why we want to partner with other people who have other NFC-enabled devices. If our platform can help you bring your product to market, come talk to us. Okay, now I'm switching to what this conference really is about. But I want to make sure that you understood why we're doing this. If this perfect storm of mobile NFC and the readiness of printed electronics had not coincided, we would not have been able to raise $173 million over the last 14 months, and without the money, you can't do it. Going back to what Raul Tamala said to me a few days ago, he said, you know, there's willow glass, there's polyimide roll-to-roll, but somebody has to take the bet. Somebody has to make the investment. And right now, in this area of printed electronics, it is Thin Film, because we're a public company, we've been able to use public markets to raise the capital necessary to make this investment. So what do you need? You need low cost, but more importantly in my mind, low step count roll-to-roll manufacturing. You also have to have capable circuits. That's why NFC and not UHF. Yes, we have made transistors at 800 megahertz. Yes, we have also made mixed signal devices. But we're focused on those things that provide high yield right now. A transistor count of around 750 to 1,500 transistors, and yields that are manufacturable not only in the front end, but also in the back end. And I'd love a lot of questions about what makes something manufacturable in the back end, but I'll leave that to the questions and answers. Now, why printed NFC? Is it purely cost? Of course not. NXP makes these chips for less than 2 cents. Are we going to spend hundreds of millions of dollars to get a penny advantage? That's not the point. The point is that by printing, by creating silicon layers on steel and then printing dopants and diffusing them, you create something that is much more robust. It has excellent dimensional stability. It is very resistant to shear, to shock, and to impact. That means you can put it on packaging. Because after all, RFID tags, they're not really encapsulated. They're not in a package. They're a die on a piece of paper. They're exposed to the elements, to corrosion, to impact, to shear. So when a test was done in Tesco with silicon chips a year and a half ago, a very significant double-digit percentage did not operate. We have done tests with Crohn's at 45,000 units per hour, and not a single one of our thin film PDPS tags did not work. Not one. 45,000 units an hour. That's the scale you need to get to ubiquity. So you also need technology, roll-based technology, but also materials, substrates, steel of the right flatness, and of course, the right dopant inks, the right silicon inks, if we go that far. So here's essentially a picture of the process. And that's why I want to say the printing is in the dopant. And I'll go through that in a little bit more detail. But a lot of the other things we do are relatively conventional. But there's some things that we omit that are very expensive in silicon. There's no ion implantation. That's why we print the dopants. Okay? And when we go roll-based, we will no longer be using steppers. And because we have relatively thin materials, the processing, the high temperature processing, can be relatively fast, which means it's of a time scale that it can be done roll to roll. Those are some of the important elements. The other elements is that we use lasers to encode in real time a unique ID on every single one of our die. So, did this come from, sort of clear blue sky? Of course not. Covia was founded in 2001 by Kleiner Perkins and Vinod Khosla. We took them over in 2014. Over $100 million had been invested so that they could make these type of NFC tags on small sheets in the fab. They had SPC charts, they had data. They didn't have yield. They didn't have a commercial product. They didn't have a reasonable price point. But they showed technology possibilities. What Thin Film had was prior experience in roll-to-roll. In Sweden, at our Linköping facilities, we had developed two different product families. The first, that you may have heard more about yesterday from Xerox, is a ferroelectric rewritable memory. The original development on that was done at Thin Film, and a number of patent families, 60, 70, 80 patents, were generated in creating these thin film memories. That was first licensed to Xerox, and Xerox has continued development on it, and it's now a Xerox product. The other set of technologies we developed were roll-to-roll printing to make electrochromic displays. We worked together with Acreo, and using many of these different features, we were able to make these two particular products. And here are examples. On the left-hand side, you see the printed memory. We've been able to print and reach up to 90+% yield on 1 kilometer long rolls. PET, typically. On the right-hand side, we do the printed displays. And this was part of the hybrid temperature sensors that we took to market in 2017. Now, we're defocusing these two areas. Why? Because the opportunity in NFC is so large. I talked about that perfect storm. So these are important technologies, and we'll come back to them. But we found that for temperature sensors, it wasn't enough to just have the displays. You had to actually have mixed signal circuits, because a temperature accuracy of 1 degree, remember it's 300 Kelvin at room temperature, is an accuracy of 0.3%. And industry actually wants a half degree accuracy. So it's difficult still to make 0.16% accuracy using a mixed signal device with a limited number of transistors. But we'll come back to this. And we have done a lot of research with our partners, including some that were mentioned earlier that also partner with CPI, on things like one-time programmable memories using the PDPS process. So I'm sure that the roadmap will get to sensors, but first I want to focus on NFC. We need to get to billions of units of volume. Our customers, like Campari, they have 1 billion units, just one customer. We've gone to market now with a major North American tobacco company. They make 900 million packages of one brand per year. We will be going to market later this month with a European-based global tobacco company. And they will be on package in duty-free stores starting in Dubai and then globally. So many of the formats so far have been loosely coupled. This is PDPS on a hang tag. This is a neck collar. We also have magnets. The next step is to actually put it on the primary and secondary packaging in high volumes. And that's when you all of a sudden need to go from the hundreds of thousands and the low millions to the tens of millions, even potentially hundreds of millions. And the only way you can do that, in my opinion, is to be able to scale beyond what the silicon industry allows you to do. Now, we will be buying silicon chips. We hope to be the largest single channel for Type 2 NFC tags in the world in 2018 and 2019. In 2019, maybe we sell half silicon and half printed. It's horses for courses. If you need impact resistance on a bottle, PDPS. If you want an insert, maybe silicon is fine, right? Because after all, we have that platform of software and end-to-end from ID management to the entire campaign management to the analysis of the data. But what's cool about this particular facility was that it was built by Qualcomm for the Mirasol project. That is, IGZO originally was the technologies they used, then they went to amorphous silicon. It was built about 8 to 9 years ago. They spent $70 million just on the fab. We were able to get it for about $2 million a year in lease because a real estate development company bought it from Qualcomm after it was shut down. It was opened in June. We got a front page in the San Jose Mercury News the day that Macron became French president. 2/3 of the front page was a picture of the fab in our grand opening. The mayor opened it with us, and it wasn't just an event. We shipped anti-theft tags from that facility, sheet-based, on the day we had the grand opening. We have shipped 25 million units of our simplest product, anti-theft tags, in 2017, with most of the production coming out of this facility already. So this is already a producing facility at 90-something% yield for that simple product. But that's sheet-based, and that'll only get you so far. Getting you so far was really the topic of Raj Apte's talk. Many of you may know that he used to work at Xerox PARC. He now works at Google X for the last few years. He's a futurist at that organization. He gives a monthly update to Larry Page and Sergey Brin about the direction of technology. And he said, you know, when I was at PARC, I thought there'd be displays everywhere. I was wrong. The mobile phone is your display. What you need is intelligence everywhere, sensing everywhere. And the Internet of Things in the sense of the Internet of Everything. Not an Intel sense of selling Xeon chips with communication capabilities, but really billions and trillions. That can only happen with additive manufacturing, such as that pioneered by Thin Film. To me, that was a defining moment. Okay, so this is another picture of the fab. Sure, we have offices and labs, but the fab is the major thing. And you have to have uninterruptible power from PG&E. You have to have gases from Air Products. That's why the Qualcomm facility is so important, because Qualcomm can have these contracts Thin Film can't. You know, I built a ingot manufacturing facility north of the Arctic Circle in Glomfjord in the late 1990s. It was the 9th largest in the world. It's still in production today, 20 years later, as Norwegian Crystals. It is one of the largest producers of N-type PV single crystal ingots in the world. But the logistics of being north of the Arctic Circle meant that we could only do relatively simple things there. The reason we're in Silicon Valley is we want to do things that are more complex than that. You can't be in some arbitrary location. You have to be able to recruit people from Broadcom, as our head of Backend came from. You have to get people from Amazon. Our head of sales was in charge of Alexa voice services for the enterprise for 4 years at Amazon. And you have to get people from the photovoltaic industry. Our head of quality is from SolarWorld. The people we recruit have 20 years or more of industry experience, okay? And so this is sort of a cautionary tale to startups. In many areas that are low capex, you can learn by doing. You can bootstrap. But we burn $6 million a month. And therefore, it's important that we don't lose a single day. Right? That's $200,000. So at the bottom, you see that we've started installing. This is an etching station. We've installed 4 of the 13 unit ops so far. So we've gotten the permitting from San Jose. We did all of the ordering by the 3rd quarter. By the end of this quarter, we will be starting to produce the anti-theft tags roll to roll at this facility. On one roll 200 meters long, you have 70 million front-end die. For NFC, it's 9 million per roll when the rolls are 200 meters long. By the end of Q3 this year, we will start producing NFC on short rolls, probably less than 50 meters, but still 100 times the batch size of when we were at sheet. So what does that do to costs? It means that the costs become essentially the cost of the material, the metal layer. So in this facility, we'll be able to make 7 billion units of front-end die, 320 millimeter wide web. The material, the steel, dominates the per die cost, and therefore it's over 10 times cheaper than even those penny or 2 penny front-end die. But does that mean that you'll get NFC for a penny? Of course not. Of course not. Conventionally, you still need an antenna. An antenna costs a few tenths of a penny. The dicing, the bumping, and we use plated bumps, and we don't even do just laser dicing. We have advanced techniques that are 5 times faster than laser. And with steel, you can't use diamond saws because the wear would be too much. So we've developed also back-end methodologies. But what I wanted to say is that even though the front-end die cost is reduced 10x, you have to talk about the system cost if you're going to make a real argument for printed electronics. But let me, before I go to back-end, talk about what we're actually doing. I'm very proud. I mean, it's all about the printing step, the dopant and viscosity, the fact that you can then coat or print. In this case, we're using screen printing, but we can also use slot die coating. And we create essentially lines that are 10 microns wide, approximately. We can go thinner as well, that have a particular dopant. So when you have created a top gate device, you then put the dopant on top of it, diffuse it into the 70 nanometers of silicon, and then you have a performant transistor. Okay? And the printing step is really what makes this entire thing roll compatible and inexpensive. So the next area that's important is the use of a laser for encoding the read-only memory. 128 bits of 256 bits. Every time we blow a fuse, we create a 0 rather than a 1. And you can see from the oscilloscope readout that there are very clear distinctions between the two different states. So all of the chips we manufacture have the possibility of having 2 different NFC states recorded, before and after. But in most cases, people only need 1 state. So our SpeedTap product has a 128-bit code. So what are some of the challenges? There are many, and I have a limited amount of time, but I do want to say that in any of these areas, if people are working on these practical questions, we want to work with you. And they're simple questions. For example, the liner. Every time you do a process step, there's an interliner that you have put between the 2 layers that are being printed on or that are being processed. And first you have to peel off the liner. You have to process it, for example, print, dry, cure in this particular case. But that's true for etching and all the other steps. And then you have to put a liner on. Is it the same liner? Is it a different liner? You know, there's a lot of questions about electrostatic discharge, about cleanliness, about particle count, about just the stretching of the liner. Is it morphologically stable? So, line speed balance versus process window. This is the game. At dinner, I talked about FMEAs. It was all about going to the equipment vendor over the last 6 months and determining at the equipment vendor, before the equipment comes to San Jose, that the process works as intended, that you have process windows that are manufacturable. Okay, and then yield impact versus cost. That's always the question. Now, going back to the back end, this is where 80% of the cost is. And this is a conventional way of doing things. After the bumping and dicing, we also do attach, conversion, and test. Now, there's two types of tests. The most important thing, and the reason that it was Thin Film that did this rather than the original owners of Covio, is that we spent years developing inline, real-time testing of rule-based manufactured components. And we then took that over to the PDPS process. Per Brooms, who invented many of these techniques, he actually did a portion of his PhD here with Friends Group at Cambridge. His PhD is from Linköping, but he spent 2 years here at Cambridge. So I just want to give credit to Per, because the testing in real time is part of the question. How do you test 7 billion devices per year? Right? But the reason I'm showing this is that since 80% of the cost is here, if we can find novel ways of creating a backend that'll be so much more impactful than just creating a new sensor using printed electronics. Lots of sensors exist, hundreds. Most are not manufacturable. If you solve this problem, you have enabled $1 billion industry. So I think it's fair that from industry, I say, what are the hard problems? Where do we need help? Right? We've made a lot of advances. We have $20 million set aside for back-end investments. So if you have ideas, please contact us. So with that, I want to thank you for your attention, and I'm eager to answer any questions you have, either about Thin Film, about NFC, or about the future of printed electronics, which we are building together. Thank you.